This last section, it's going to have two parts to it. One part is we're going to look at what's referred to as a box plot. And when you guys did the Khan Academy the other day, and I showed you that one thing that looked something like this, and some of you were asking about, that was a box plot. So we're going to see what that means today. And then we're also going to find a way, we talked about outliers a little bit, but so far we've just said, well, it's a lot bigger, a lot smaller and everything else. We're going to have a rule for how we can figure out if it really is an outlier for our data. So we're going to start with that. Well, if I'm going to try to identify if I have an outlier in my data or not, what we're going to use is what's referred to as the 1.5 times the IQR rule. And the rule is basically telling you what we're going to do, at least initially. So if I gave you this set of data, and I ask you if there are any outliers in the data, well, in order to actually make that decision, I'm going to have to use the 1.5 times the IQR rule. But I can't use this rule unless I know what the IQR itself is. So we've got to figure out what the IQR is, which means I need to know what Q3 is and what Q1 is. Well, we can punch these into the calculator and do our 5-number summary like normal. So let's go ahead and start with that. Go ahead and punch those values in, and we'll find out what our 5-number summary is, because that'll tell us what Q3 and Q1 will be. I put that data on the note sheet, didn't I? Or the number sheet. Okay, hopefully we're getting comfortable with that part on the 5-number summary. Like I said, in order to use this rule, we need to know what the IQR is. So the IQR, again, is going to be the Q3 value, which is 17, minus the Q1 value, which is 10. So for this situation, our IQR is 7. Now remember, the IQR really is telling me the range of my middle 50% of the data. And if I think about for this situation, Q1 is here at 10, and it goes across Q3, which is a 17. So this was the IQR part. That's the middle part, or kind of the meat of our data. Well, if I'm going to have an outlier, the outlier really has to fall on that high end or the low end, because it's one of those values that's kind of out by itself. So what I'm going to do is I'm going to set up some parameters for myself. I'm going to try to figure out, okay, well, how low can I go and still be okay, not have an outlier? Or how high can I go and still be okay and not have an outlier? Well, both those decisions are going to be based on my lowest value so far, which is Q1, and the highest value that I've looked at so far, the Q3. So let's start with the Q1. Well, this rule says I want to take 1.5 times whatever the IQR is. So we just decided the IQR was 7. So I'm going to take 7 times 1.5. And if I do that, I'm going to end up with 10.5. Now, 10.5 is not my marker, but it's something I'm going to use. Because what I'm going to look at, first of all, on the low end, is from my Q1 value, if I were to take away 10.5, that's going to be as low as I can go without having an outlier. So I'm going to take Q1 minus whatever I get here and see what that answer is. Or in this example, I'm going to take 10 minus 10.5. Well, 10 minus 10.5 is a negative number. So this is my lower limit. In other words, as long as I'm not lower than negative half, I'm in good shape. Well, my data never even had any negative numbers, so I'm in good shape on the low end, which means I don't have any outliers on the low end. Now I need to shift gears and look at the high end. Well, again, I'm going to start at the highest value I've looked at so far, the Q3. This time I'm going the other direction, so this time I'm going to add that 10.5. Or in other words, I'm going to take Q3 plus what I got here. So on the low end, I subtracted off of Q1. At the high end, I added onto Q3. Well, for this example, Q3 was 17. I'm adding that same 10.5 that I came up with. So my upper limit is 27.5. Which means if I have anything past 27.5, that would be considered an outlier. Well, that happens this time, right? We get 35. So because I have that one value that's higher than 27.5, I would consider this value to be an outlier. So I'd say 35 is an outlier. And in this problem, that was the only one. It's possible to have more than one outlier. It's possible not to have any outliers. We don't have to have an outlier with our data. So if we kind of back up to our steps, we had to find out what the IQR is. We're going to use the rule, the one that says IQR times 1.5. Then I've got to use that number to help me. The way I use it is I take it away from Q1, and that's my lower limit, and I add it on to Q3. That's my upper limit. So anytime you're doing a problem where I ask about the outliers, I always want to see what's my lower limit, and I always want to see what's the upper limit. You should always give me those two values before you say, yeah, there's an outlier, no, there's not an outlier. Question?
So once you get the Q1 and Q3, it's just the next number. That's going to be the IQR you add.
So remember, IQR is going to be, once you have these two values, we're going to subtract those two values.
Okay.
So that's where the IQR itself will come from. It's Q3 minus Q1.
Okay.
And then once you know that, you multiply by the 1.5, and then we'll start using that number.
Okay.
So it seems a little bit tricky at first, but if you use the rule, it's just a matter of adding it on one side, subtracting it on the other side. And make sure you do that from Q3 and Q1. So again, if you have a problem like that, always show me what's the lower, what's the upper one. All right, well, the second part of this is going to use the outlier eventually, but we're going to use what's called a box plot to display our 5-number summary. So we've been doing these 5-number summaries, and I think you're good at doing those on the calculator. Now we're going to use a box plot as a way to display that 5-number summary. Some things about a box plot, kind of like a dot plot, it'll only have a single axis. Most of the time it's going to be horizontal. Just like a dot plot, we're going to mark it like a number line. So you got to have an interval. So here's how we're going to make a box plot based on using that same data that we just used. Well, the box plot again is going to show our 5-number summary. So we've got to do our 5-number summary. But we just did that. So the 5-number summary, we had a minimum of 8. Q1 was 10. Median 15. You always got to start there. Like I said, we're going to have a single axis here. We're going to label like a number line. So we need to figure out what we want to go by. We're going by 2s, 5s, whatever. Well, if I'm going from 8 all the way up to 35, we're looking at something that is about, what, 27. So if I were doing this one, I would probably maybe start at 5 and go by 5s. Notice I didn't just label the numbers that I wrote down. I chose an interval to go by. All right, so we're going to do our box plot. Sometimes these are called box and whisker plots. You may have done those before. But the box part of our box plot is going to start at Q1 and it's going to end at Q3. So I'm going to start at 10. I'm going to end at 17. And I'm going to make that rectangle, that box. Now, I usually like to label across the top as well, especially when I had to go by, in this case, 5s. You don't have to do that part, but sometimes it's a little nicer. So again, the box part starts at Q1, ends at Q3. Wherever the median is located, we're just going to put a vertical line. So 15, I'm going to put a vertical line inside that box. All right, from there we're going to make the whiskers. Now the whiskers, in general, are going to go to the lowest value and the highest value. The only exception is if we have an outlier. Well, let's think about on the low end here. Well, we decided earlier we didn't have an outlier on the low end. So what I'm going to do is I'm going to draw a whisker out where 8 is. So I'm going to go to where 8 is. I'm just going to draw out that line there to 8. On the high side, well, if I didn't have an outlier, I'd do the exact same thing. I just draw my line out to the highest value. However, we decided 35 was an outlier. So we're going to mark that differently. The number that was an outlier, I'm going to go to it, and I'm going to put an asterisk there. I'm going to put kind of a star there. But I'm not going to draw out my whisker to it. I'm going to draw my whisker out to the next highest value. So the next highest value is 18. So my whisker is going to be pretty short. And the reason we do that is if I were to draw that whisker out, it would make it look like it was really spread out. But really, most of my data was down here on this end. We just happen to have that one value. That was my design. Now, if you didn't have an outlier, if 35 was not an outlier, I'd just draw it out there, mark it, and that would have been good. Yeah, but anytime we have an outlier, we want to make sure we mark it. So that would be my box plot. You would want to include a title, but I don't even think I gave you any context to this. So just make sure that you have your title on there, whatever you happen to be dealing with. So we'll practice some more with box plots on Friday. And then on Friday, like I said, we'll work some more with box plots, and then I'll start explaining our Chapter 1 project that you're going to do. And then we'll work on our Chapter 1 project that next week, for at least 2 days on the next week. So for right now, I'm going to hold off on giving any problems related to the box plots because I want to practice some more because I really did one example. But I want to make sure we have enough time. Like I said, I had this labeled as a quiz. It's really just kind of a graded assignment, so it would be something that I'll grade as far as correctness. But it's going to be related to section 1.6 and 1.7. Okay, you can use your notes on this like normal.